This is the Chapter 9, Lesson 2 video, significance tests about a population proportion. So keep in mind that means we'll be talking about p-hat. That's the proportion, that's a sample statistic, and p would represent the true parameter. So your guiding question, how are significance tests and confidence intervals different? Which provides us with more information and why? I'd like you to think about that as you watch the video. Think about how they're similar as well as far as determining something about a parameter. So when we go through these tests, just as we talked about in the Lesson 1 video, we're going to state the hypothesis we're testing and the significance level. Remember, 5% is widely accepted, but we've looked at 1% and 1/10%, so you can define different significance level. Remember, the smaller the value of our p-value, the stronger the evidence is against our null hypothesis. So the lower alpha is, the harder it is to reject the null hypothesis, because then your p-value has to be lower than alpha to reject. Plan by naming the procedure you plan to use. Is it one sample z? Is it one sample t? In our case, it's one sample z for a proportion. Remember ZAPTAX, z for a proportion, t for a x-bar for a sample mean. And then check the appropriate conditions, random, normal, independent. Do the problem by calculating your test statistic. And you're going to determine a p-value, which is a probability that the statistic is the value you got or more extreme given the parameter that you hypothesized in your null hypothesis. And then you can conclude by using the p-value and the significance level, which is alpha. Remember, that's the significance level alpha, to make an appropriate conclusion about the hypotheses and context of the problem. That means if the p-value is smaller than alpha, we reject the null hypothesis and assume the alternative. If the p-value is larger, then we fail to reject. Remember our conditions: random, we need an SRS. If it's an experiment, a random assignment as well. Normal, remember for a proportion that we need n times 1 minus p and n times p to be greater than or equal to 10. So our test statistic is just going to be like z-scores that we've looked for over the course of the year. It measures how far a sample statistic diverges, or how different it is from what we would expect if the null hypothesis is true. So in standardized units, which means the unit is, we divide by standard deviation the statistic, so we can see how many standard deviations from the parameter our test statistic would be. So basically we assume the null hypothesis is true and see if it's true how likely or unlikely it would be to get that p-hat, that test statistic. So we do our sample statistic minus our proportion hypothesized in the null hypothesis, and this will give us our test statistic. Based on whether you'd rather make a type 1 error, reject H0 when it's true, or type 2 error, we're going to choose a significance level. We'll talk about that more in class based on the alpha you'd want. Whether you remember type 1 happens, remember when type 1 and type 2 happen. So our two possibilities: we reject H0 and it's actually true, that'd be a type 1 error. We fail to reject and it's false, that's a type 2 error. So the alpha level will help us deal with that, which mistake would be preferable. A two-sided test implies we're looking at both the left and the right of the normal curve, so we'd have a not equal sign for our alternative hypothesis. That just means the value could be smaller or larger. One-sided test would just involve less than and greater than signs. So our value is the portion of the graph under the normal curve that doesn't include the values in H0 for both of those. When you have a not equals, you'd find the value for a one-sided test and then double it, since it's on the left and the right. So it turns out confidence intervals give us more information. So we can get more information because the result of our significance test is reject or fail to reject. An interval gives us an estimate of the plausibility of the hypothesized parameter. So like it gives us how far we off in the range. Like where's our 95% confidence interval? How far is the statistic from that? Whereas our significance test is going to tell us whether we reject it or not. It gives us a p-value, but a confidence interval gives us an interval of values where it could be. So confidence intervals can give us more information. They're somewhat similar to two-sided tests, which we use when the not equal sign is used. So that means we're looking to the far left or far right of the normal curve to compare. So basically a significance test can tell us if something's plausible or implausible. Since the confidence interval gives us a point estimate and a range of values, it gives us more information. So let's refer back to the problem we had from the first lesson, where we had an SRS of 100 people. We're going to use a significance of 5% here for alpha in order to carry out this problem. So first we check to see if it's random. Is it random? Yes, if there's an SRS. Is it normal? So think about the normal condition. This is proportions. It's going to be n times p, and n times 1 minus p have to be greater than or equal to 10. Here we have 0.56 times 100 is 56, and 0.44 times 100 is 46. Another way to think about that is just the numerator of people in the proportion. Both numerators need to be bigger than 10. So 44 over 100 is bigger than 10. 56 over 100 is bigger than 10. Maybe that's an easier way for you to think about it. And independent, we'd have to assume that there are at least 1,000 people total in the population we're drawing from. Remember the 10% condition, and that one's the same for sample means as well. So we're good to go. All of those are checked off. So your goal is to calculate the test statistic, the statistic minus the parameter over the standard deviation using this formula, p hat minus p over the standard deviation of the statistic, which is the square root of p hat times 1 minus p hat over n. And actually, correction, that standard deviation should be in terms of the parameter, not p hat. So that should be the standard deviation you use as the bottom. So calculate the test statistic. Use your calculator, normal CDF, the test statistic you get, and n. Remember, n is our sample size, which was 100. Compare it to the significance level of alpha equals 0.05 or 5%. Remember, our p-value, if it's less than that, then we're saying we reject the null hypothesis because there's less than a 5% chance that we'd get that statistic based on the parameter being true. And if our p-value is greater than the alpha, we fail to reject. Here is your multiple choice to do that with. So go ahead and pause right now and determine which of these is the correct answer based on those calculations you did up there using normal CDF.